Hi everyone, my name is Francesco and I'm CEO and co-founder at Osmoses. We're a clean tech company based in Boston where we're transforming molecular separations. And why this is so important and everybody in this room is affected by this? Well, the cost of unmixing, separating and purifying molecules is massive, both for the industry and for the environment. We're talking about 15% of the world's energy wasted on inefficient separations and 16% of carbon emissions that depend on the fact that we still rely on century-old technologies to perform these processes that are critical to enable the industrial infrastructures. These numbers are so big because separation processes are literally everywhere. They define the backbone of chemical, petrochemical, and energy industry. And this is why our mission is to eliminate the energy waste and decarbonize industrial processes with transformative separation technologies, and in particular, molecular filters. We are commercializing breakthrough science. We have developed a platform of polymer materials that, when manufactured in very thin membranes, they leave behind porosities that have the same size of that of gas molecules. And why gas molecules is such an important place to start from for us is because that's where there's the biggest and unmet need in the market. It's extremely difficult to separate gas molecules, and this is why our solution is so special. We're not the only one believing so. In fact, we're backed by top-tier VC firms, and also we have projects with government agencies in the US. We're going to start from low-carbon molecules that are so important to decarbonize the industrial network for gas, which are biomethane and hydrogen. These are growing market, distributed solutions where membranes shine the most, and we have an attractive value proposition to tackle those problems. But this is really just the beginning for us because we have a platform technology that can apply into many verticals in the energy transition, including carbon capture, helium harvesting, and so on. Markets that are already $15 billion and destined to grow to more than $35 billion by 2030. Our leadership team got started in 2016 as a research project between MIT and Stanford. We incorporated in 2021, and now we're 15 people with expertise in engineering, chemistry, material science, business development, and so on. We spent 2022 scaling up our membranes, growing our team. We're full speed building our prototype modules and partnering with companies so that we can start piloting in 2024 and have commercialized solution as of 2027. We really cannot wait any longer to decarbonize industrial processes with transformative separations technologies, and I hope what I share with you today made a good case for why this is so important and why Osmoses is best positioned to tackle this challenge. Thank you so much.
Sandy?
What differentiates you from other competitors?
Absolutely. So the materials that we've developed that we published in Science magazine just last year showed the highest possible selectivities that have ever been recorded for membrane technologies. Why selectivity matters is because that's really proportional to operating cost. And this is one of the reasons why traditional membrane technologies have failed in conquering more than single-digit % of the market in a lot of gas separation applications. So we believe that that is going to unlock the promise that membranes can deliver sustainable solutions for gas separations, and we believe that there is going to be a differentiating factor that is going to deliver on value for customers.
What are the main challenges to scale up your solution, if any?
Yeah, this solution is complex in a way that requires a lot of skills. We need to commercialize polymer materials and scale them up. We need to make membranes at larger scale, so there's a manufacturing skill both on the production of the polymers and the production of the membrane technology itself. But I would say also one of the biggest challenges is making sure that the industry is ready for a technology that is different than the state of the art, which is mostly based on thermal processes. So it would require a transition, which is what the energy transition is all about, but we need to make a good case for that and convincing somebody also to take a risk in changing how things are done today.
Can you give us some elements or some numbers about the efficiency that your technology is providing?
Yes, absolutely. So when it comes to operating cost, we looked into a couple of applications, for instance, biomethane recovery, and we have a reduction in operating cost that can go up to 40 to 60%. And this is very impressive when it comes to energy efficiency. And this is mostly related to reducing the compression costs that are necessary in these systems, and also reducing, for instance, the number of stages that are necessary to deliver the same recovery and kind of purity in these solutions. So, and overall, again, like the main comparison is against the thermal processes, which now require, like distillation, amine absorption, that require significant amount of energy to be performed. So it's a completely different approach, and that's really where the membrane shine the most.
Did you already identify the partners to manufacture membranes, polymers?
So we have a couple of options. Most of this is done now in-house because it's a scale that we can handle the partnership and the collaborations that we have already with our partners. But long-term, we're planning, of course, to scale this with commercial manufacturers. We have identified them. We're picking the best. If they're listening, you need to make a good cost for us and make sure that they're going to be lined up to work with us. But yeah, and also we're working in-house now because of IP. Very important for us to retain the IP in-house. Time's up.
Thank you very much.
Thank you.
Thank you.